Hello all. In this video we will go over IBM BPM / BAW Event Manager. So Event Manager contains four types of event queues. One is for async queue. This is for UCS. By default all the UCS runs on async queues, and it has a queue ID -100. So by default its capacity is 10. Okay, and so what does it mean is at a time it processes 10 event manager records at a time. Also you can create synchronous queues for UCS. The queue ID will be generated by the system. Most important asynchronous queue is BPD async queue. So this queue will be used for all the BPD notifications, system lane tasks, timer executions. So that means when the token moves from one task to another task, that task will go into this queue and will be executed. So so this queue is responsible to execute these three tasks. And another one is system queue. So this is purely for internal EM tasks. For example, when you create blackout periods, so those specific tasks goes into the system queue. We don't need to worry about this. So each queue has the capacity by default. What does it mean is at a time this queue can take in 10 EM records and then execute them. Now let's see how the event manager execution works. So let's assume this is the BPD asynchronous queue, okay, and it has the capacity like 40. Okay, so 40 is at a time it can take 40 event manager tasks and then execute them. So this is normal behavior. If everything is good, this is how it should work. So in this queue, so thus event manager records will have a schedule. Each record have executed at the time. So when the time comes, for example, let's take a task that is scheduled in the future, which are represented in blue color. So what happens is the task will move to the acquired status and then move to the executing status, and then it gets removed from the EM table. Acquired status is very short-lived status. Sometimes due to the large load or some other issue, okay, so your event manager table may get performance hit at the time. So let's see how it works. So as you can see, this is the asynchronous queue, and then you have scheduled for future. Okay, there's no problem with this. So earlier it directly went to scheduled for future to acquired, but since your event manager asynchronous queue is not working properly, that means it is taking more time to execute the tasks. Okay, it's heavily loaded, so that then the scheduled, there may be records which have the past schedule. For example, it's supposed to execute at 9 a.m. okay, but even after 9:30 its status is still 1. That means it's past the schedule. Okay, so these type of records will wait. Okay, so once this queue is freed up, okay, then it will go to acquired and then to the execution mode. So the settings I have shown you, these three can be found in the running teamworks. So I'm just grabbing. So you can see the asynchronous capacity is 10, and sorry, synchronous capacity is 10, asynchronous capacity is 10, BPD queue capacity is 40, and system queue capacity is at 10. But at this time we are focusing only on the BPD queue capacity, okay? And then we will throttle this, meaning we will decrease the capacity to 3 or 4 and then see how it impacts. But for now we will keep it at 40 and run some tests on it. So for creating the load on the system, I just created a simple BPD. What it does is, it goes to the system task. There I am throwing some error, and when it encounters error, a task will be created. But immediately it fires the timer. I'm keeping the timer at 0. That means the token moves again here, and then here if it is counter is greater than 2000, just it goes in the loop and loop. So that way we can create hundreds of tasks same time. So let me fire this. So you can see task token is 78. See, already it's went to 77, 141, 150. So this will go, it will continue. So I am creating such BPDs, like 10 of them. So similarly I have created another BPD. It's the same. The difference is this timer fires at after 1 minute based on the counter. What I mean is, if the counter is even number, it fires, it waits 1 minute and then fires. If the counter is odd number, it directly fires at 0 minute. It just to create some future scheduled tasks, so that we can see that in them in the EM table. Just 2 of them. Okay, so now I just ran this query, the EM task table. So you can see some of them are in execution status, actually most of them. Some are in status 2, which means acquired. Some are scheduled. Okay, so now let's analyze these metrics via Datadog. So I am logged in my Datadog portal. So Datadog is just takes the queries, whatever you keep as counts, and then you can analyze those. Because I have all these queries in the SQL developer, but I want to see them visually in Datadog. So I integrated BPM with the Datadog so that we can watch these metrics visually. So it's experimental stage. Okay, so I created this simple graph. So let me go over what it is. The first one. So this green line, it showcases what are the current tasks, current EM tasks that are executing. You can see it there, it is execution mode. So it takes metrics every 10 seconds. I configured that way so that we can analyze clearly. So you can see at a time it is processing 10, 13, 14, but we put the capacity at 40. So as long as it is below 40, I mean it won't cross 40, but if it is below 40 we are good. And another one is, these are the tasks that are in acquired stage. So that means before execution some tasks go to the acquired state, right? So these are the count of those tasks. So you can see at 7, some of them are 4. And next one is, some may be past scheduled. So remember, if you remember the PowerPoint, so we have some tasks that may be scheduled that may be waiting to get executed because their time came, but there is no enough space. Asynchronous queue is busy processing the other tasks. So these are the blocked EM records. So let's see if there are any. See, most of the time it is 0 or 1 at the max. So let me remove the first 3. See, most of the time it is 0 or at max 1. So theoretically, it should always stay 0, but sometimes my processing power is low. If there is if the thread pool is busy, then it may go above 0, but it's ideal to have it discounted 0. Since I'm counting it every 10 seconds, so you're seeing these fluctuations. But if I take the count like every 2 minutes, it may be almost straight line. And next one is, so this is the total count. So total EM count, so that means it covers all the tasks, EM tasks. So if you can see it's almost similar. If I select both of these, it's almost similar. And the last one is future scheduled EM tasks. So this means, if you remember let me go back to there. So see, some tasks may be scheduled for future, so there is no problem with these tasks. That means their time did not come, so that's why they are scheduled for future. So these tasks are not problematic, but these are, because their time came but they are not yet executed. So this should be fine, but most of the time you see it's almost stay the same, like straight line. So now we can say if the currently executing tasks reached the 40, okay, and if the past scheduled tasks are more than 5 or more than 6, or then we can say that okay, your EM is backed up. But if so this is how the normal processing looks. So your queue capacity is at 40. These are the total tasks, and the next line is the currently executing, and this line, blue line, is the future scheduled task. There is no problem with that. And the cyan one, this color, is the acquired EM tasks. That means that short-lived tasks, and the red ones are the past scheduled tasks. So since they are almost 0, so I don't see, we can safely say that okay, there is no problem with the processing of the EM. So now let's try to put more load on the system. So either you can create more tasks, okay, or it can decrease the queue capacity. So right now my custom queue capacity is 40. So what I will do is I will reduce it to 4 and then see how the system behaves. For that, we can change this property in the 100 custom XML and then restart the app cluster. So let's check if our changes have taken place. So you can see BPD queue capacity is 4 and remaining as it is, as they were. So you can see the same thing, and then you can say, right, at a time, this execution is 1 2 1, so it won't go above 4. So, and see, some of them, most of them are in scheduled state. So now let's see how it's looking in the data log. So past 5 minutes, let's see the past 15 minutes. So you can see, the executing task went down because we restarted the server. That's why this counts went 0, but this stayed same because it's the total number of the EM tasks. Okay, so maybe this from here we need to analyze for the sync capacity 4. Okay, see, the total tasks are 17. Okay, total EM records in the sync queue, but this time you see the red line is above than the executing task. That means the past tasks, these tasks they're scheduled, but their time came, but they're not executed yet. That's why the red is above the. And let me remove all this. So you can see the count is at max at 4, and it is taking 3 at a time, 2 1. Now let's see the acquired tasks. So acquired tasks, you can see. So now if we see the acquired tasks, past scheduled tasks, see, there are almost 15. That means 15 tasks are waiting to be executed. Their time came, but they're not yet executed. And if you see that, this is the total number of the tasks this queue contains. And this is the scheduled for future. So there is not a problem with this because they stay the same. Then their time did not come yet. So this is how you analyze the metrics. So based on your system, you can set alerts here. For example, if your acquired tasks more than this particular number, that means your EM is backed up. Thank you guys, that's all for today.